always targeted at some audience, and you hope you're hitting the audience of the people who are using it. And that's usually not true. Somebody picks it up that's totally from a different world, and you realize you didn't do the right thing. We have solved that in a bit. We have an example for most of the words. So if I say example average, it actually runs a little deck of cards, if I can use that terminology. And that's actually been done with Speakeasy. That is not a document. So you can see how it's actually used. That's very important because we actually use that as part of the test of our validity of Speakeasy, is to run all the examples to see that they do what they're supposed to do. And a user then knows what it does. You can see it right there, and it's clear. We also have built-in tutorials, lots of things that help users. The most recent one we added was that you still can't find some word, so we added something called keyword. So if I say keyword graphics, it gives me a list of words which are the words that are associated with graphics. We have gone through our entire document and put keywords in everything. Turns out there are more keywords than there are documents, which doesn't sound right until you start doing keywords, and you'll soon find out that's true. Now this may help, but if it doesn't, I can use this result. This is answer, by the way. If I type answer, you see that that array of names is an answer. And I type in another word in Speakeasy, which is first line of answer. So that's using answer, which are these document names, to give me the first lines of each of those words. So I can sit there and scan and see what each word does rather easily. This is what I was saying earlier. We've invested a great deal of effort in trying to make this thing humanized. And that's really our forte. The mathematical routines that we show you, eigenvalues and stuff like that, we didn't write those. We don't claim to be numerical analysts. We are using library routines that are valid, good ones. And that's very important to us. I was at Argonne. I was very lucky. There's a very good math division at Argonne. They develop lots of routines. LinPack is one of them. They have IcePack. If you say in Speakeasy, I haven't shown you the matrix algebra. I'll show you how easy it. We're still going on with this documents here. There are an awful lot of, I see one of them has a little error. So you saw there were quite a few documents that relate to graphics. That's because it's a popular field. Let me just define a matrix and show you how easy it is to do matrix algebra. I'm defining a 3x3 matrix. I say x equals matrix, open parentheses, 3, 3. Those are the number of rows, number of columns. And then I just feed a bunch of elements into it. And hopefully I didn't feed more than 9 because it would complain. If they're less than 9, it puts zeros in. So this is a matrix in the mathematical sense. If I multiply x times x, it does matrix multiplication. If I want the inverse of the matrix, I say 1 divided by x. There's the inverse. I can check it by multiplying answer times x. And you see the 1s on the diagonal. You see the funny little numbers off on the off diagonal, which most of you understand, but there will be people who don't. If you say set null 1 e minus 8, that says I don't want you ever to print a number less than 10 to the minus 8. So if I look at answer now, it makes you look a little happier. Now we have funny things. I could print this in Roman numerals if you like. Built into Speakeasy is a thing called print specifications, which says how X should be printed, how Y should be printed. And we've put that in because one of the students that I had was, as a joke, had just learned how to do Roman numerals on a computer. So we put it in as fun, and we got back a complaint. Namely, they wanted lowercase. We had only done the uppercase Roman numerals. We've never done the lowercase. I think we could probably do it now with other operations in Speakeasy. Now, I want to describe one aspect of Speakeasy that's very important. We have a vocabulary, a very large vocabulary, and what happens is that the power of the language multiplies every time you add a new word, because the words combine with other words. It's not like a package that does, you know, if you have a routine that does a big analysis, then you have to add to that routine to increase its capability. In Speakeasy, if I add a word that, I don't know, does the sum of the cubes of elements, you then merge it with other things, and it turns out it's more powerful because of all the other operations. And that's what's sort of exciting over the last few years. The language is so complex in terms of